we have started with the always block, and we have also seen the event controlling in the always block, and we have also seen what is meant by this procedural assignments, what is meant by this procedural blocks we have seen, and we have also seen how this particular always block events is working, and we have also discussed with the what is meant by synchronous reset, what is meant by asynchronous reset we have seen, and how this particular synchronous reset is working with respect to the clock, and how asynchronous reset is working, and how to code for synchronous reset design, and how to code for asynchronous reset design also we have seen in our yesterday previous session. So is it clear up to here? Are you having any doubts or queries? So let us start with the topic which is known as blocking assignments. And yeah, so within the procedural blocks, like always block or initial block, you can take any block if you want. Let me take always block, always at the rate some passage of clock. I will take passage of clock. Begin A is equal to 0, B is equal to 0, hash 2, C is equal to 1, D is equal to 0. So this is my code which is written inside a procedural block like an always block. Okay. Now, so this statement inside a always block, this everything will be executed sequentially. This we have already seen in our previous sessions that the execution flow is in a sequential manner. Now, so what is mean by the sequential? First, this A is equal to 0 will be implemented. Okay. Then after B is equal to 0 will be implemented. And this hash 2 indicates that after a time delay 2 units, after time t is equal to 2 units, C is equal to 1 will be implemented, and after that D is equal to 0 will be implemented. So here we are using a blocking statement. This equal to is known as a blocking operator. Okay, what it is called? It is a blocking operator, which means it will block the execution of further, it will block the further execution actually. Okay, so here what is happening? Up to 2 units, up to 2 time units, this C is equal to 1 will block the execution of D is equal to 0. After 2 time units only, this D is equal to 0 will be executed. This is nothing but a blocking assignment. Is it clear for everyone? So let's say if we have written A is equal to 0, hash 1, B is equal to 1, hash 2, C is equal to 0, hash 3, D is equal to 1, and hash 5, E is equal to 0, and F is equal to 1. Now tell me when this particular F is equal to 1 will be executed, at what time F is equal to 1 is executed. So here, see here carefully. So what happens is, in the case of blocking assignments, in the case of blocking operators, when we are using this blocking operator, the delay values get added. So here what is the delay value? Here it is 1, and plus 2 3, and plus 3 which is equal to 6, and plus 5 11. So after 11 time units, F will be equal to 1. Okay, so this is how, when we use a blocking operator with a delay, this is how it will get executed. So the delays will get added actually. Okay, in the case of blocking operators, I am talking about blocking operators. Now in this code you can see we have declared reg a comma b comma c, always at the rate passage of clock. Begin A is equal to 1, B is equal to A, C is equal to B plus 1. Okay, assign value of B plus 1 to C. Okay, this is how a blocking operator will work. Is it clear? Yes. Next, coming to concurrent assignments, evaluates all the right hand sides first, then updates the left hand side simultaneously. Typically used in sequential logic to avoid the race conditions. So we have another type of operators which are known as non-blocking operators. Non-blocking operators. So what is this non-blocking operator? Let's say if we have always at the rate let's say passage of clock, begin, A is equal to 1, hash 2, B is equal to 0, C is equal to 1, end. So can anyone tell me at what time C is equal to 1 will be updated? At what time unit I am executing my C is equal to 1 is getting executed? Because we are using a non-blocking operator. We are using a non-blocking operator. This non-blocking operator is not going to block the further executions. So, and one more thing, remember this non-blocking operator, if we use this non-blocking operator, everything will run parallelly. Okay, so nothing is going to stop anything. Okay, this particular block or this particular block will not block the further execution, that is B is equal to 0 will not block the further execution C is equal to 1, or A is equal to 1 will not block the further execution B is equal to 0. So at time t is equal to 0 only C will be equal to 1, and at time t is equal to 2 only B will be equal to 0. Is it clear for everyone? Now let's say if we have used A non-blocking 0, B non-blocking 1, C hash 2, okay, this we will discuss later, hash 2, C is equal to 1. Okay, for now I am just introducing my delays here on the left hand side only. Okay, now so if we are using a non-blocking operator, actually what happens is if we use a non-blocking operator, the right hand side value will be stored inside a temporary register. Okay, the right hand side value will be stored inside a temporary register, and at the end of the simulation it will be it will be assigned to the left hand side. So what happens initially, this particular 0 will be stored inside a particular temporary register. Okay, and after this particular end of simulation time it will be stored into the left hand side. If you have a delay, let's say hash 2, A is equal to 1. Okay, then what is happening at 0 time unit only, this 1 will be stored inside a temporary register. This 1 will be stored inside a temporary register. Then after at the completion of this 2 time units, the value which has been stored inside this temporary register will be assigned to this A on the left hand side. So this is how a non-blocking assignment works. If you have A is equal to A non-blocking of 1, then what happens? 1 will be stored inside a temporary register, and after that it will be stored into this particular A. Since there is no time delay specified here, at 0 time unit only everything is happening. If you have a time period specified, then according to that completion of that particular time period, your right hand side value which has been stored inside the temporary register will be updated towards the left hand side. Okay, so this is how a non-blocking operator works. Now, so if I have a requirement, let's say a uh, non-blocking of 1. So this is a non-blocking assignment. This is a non-blocking assignment. This I want to implement using only blocking operator. So how can I write the code? Any idea? Any guess? Any try? So this is my non-blocking operator, A non-blocking of 1. How can I represent the same execution inside using my blocking operator? How to execute this non-blocking assignment, A non-blocking of 1 using a blocking operator? A non-blocking of 1. This I want to implement it using a non-blocking operator. So how can I implement it? Any idea? Value will be stored inside this A. So how to represent it in blocking operator? This we can use a temporary register. We can declare a reg called temp. A is equal to temp, and we can write afterwards what we can write. A is equal to temp. Sorry. Temp is equal to 1, and after that A is equal to temp. So this is how we can write it using a blocking operator. Is it clear for everyone? So I hope you have got a clear idea about what is meant by blocking, what is meant by non-blocking, what happens if we use a blocking operator, what happens if we use a non-blocking operator, right? Now, so this is how we can use this, and you can also slice a vector if you have declared a vector. Let's say rich 7 down to 0 a. You can simply slice your vector always at the rate passage of clock a of 2 is equal to 0. That is, the second bit will be equal to 0. A of 1 down to 0 is equal to 3. Like this also, you can slice your vector on the LHS side. Okay, this is known as vector slicing. Okay, so let's say if I have declared range 7 down to 0 A, that is, I am having a vector of 8 bits. 0, 1, 2, 3, 4, 5, 6, 7. Okay, I'm having a vector like this. Now, within an always block, or you can also use an initial block, always at the rate passage of clock or negate of clock, anything. Okay, begin a of 2 is equal to 0. That is, you are assigning the second index to equal to 0, or you can assign 4, 5, 6 a of 4 down to 6 is equal to you can give 4 5 6 3 tick binary 0 1 0, like this also you can give, or a 4 down to 6 3, like this also you can give. Okay, so this is nothing but vector slicing. It is called as a vector slicing. Basically you are slicing a vector, that's it. Is it clear now? Yeah. Now tell me, what is the value of a of 0, a of 1, a of 3, a of 7? Any idea? Okay. Yeah. I think we can end this session with this.